All right, what's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, I'm going to show you how to find the slant asymptote given the factored form of a rational function. So the first thing that we're going to do is go ahead and take a look at the following function. Now you'll notice that this function right here that we've got, this is in what's called factored form right here. So what we want to do is notice a couple things about this function. First of all, this x plus 2 factor on the bottom, that's going to be a vertical asymptote. All vertical asymptotes always go on the bottom. Now you'll notice a repeated factor of x minus 6 on the top and the bottom, so that'll be in both the numerator and the denominator, and that's going to be a removable discontinuity or hole. So those are going to be some pieces that you'll need to pay attention to when you set up functions sometimes. So there's our removable discontinuity right there. And then these other two guys, the x plus 3 and the x plus 1, both of these are x-intercepts. So both of those guys are x-intercepts. X-intercepts always go in the numerator. Now this 1/2, that's right here, even though we don't write a 1 in front there, we've got a 2 right there. So that's going to come into play later on with a few things. So we'll come back to that in a little bit, but that's how we set up our factored form of a function that is rational. So pay attention to all those little pieces, where they go, and their locations. All right, now from here, what we've got to do is take our time and come up with the expanded form version. All right, so in the expanded form, what we're going to do first is I'm going to take these two guys, these first two functions right here, or first two factors, I'm going to multiply them together. Now when we do that, we're going to end up with an x squared, and then plus 3 and minus 6, they give you negative 18 when you multiply them. And when you add plus 3 and negative 6, you'll get negative 3x. So that's that first trinomial. Then that x plus 1 factor, just leave that on the outside. In the denominator, we're going to leave the 2 there. Then we'll do kind of the same thing. We'll multiply these two binomials together. And the x, when you multiply that by another x, you'll get x squared. Plus 2 and minus 6, when you add them, you'll get minus 4, so that'll be your middle term. And plus 2 times minus 6 gives you negative 12. Now, one more piece that I need to do is multiply this top trinomial with that binomial right there. So what we're going to do is we're going to set that up using the box method. So with the box method, you'll set it up just like this. So that x squared minus 3x minus 18 will go along the top, and then the x plus 1 will go on the bottom. Here, just take your time and multiply each one of the terms together. So when I multiply x by x squared, that is going to give me x cubed. When I multiply x by minus 3x, that is going to give me negative 3x squared. And then lastly, x times negative 18 gives me minus 18x. So that is for the terms that I get when I multiply everything by an x. Now, when I do the same thing, got to erase that part. When I do the same thing and I multiply everything by 1, so this time I'm going to multiply everything by 1, so I'm going to get x squared minus 3x minus 18. Now from here, these terms will be combined, as will these terms. So when we write our final version of our polynomial answer, we're going to do two things here. So that first one, in the numerator, we're going to have an x cubed, and then we're going to have x squared and minus 3x squared give you minus 2x squareds. And then negative 3x and minus 18x give me negative 21x. And lastly, we have our constant, negative 18. In the denominator, though, so now we got to distribute the 2 to each one of these terms. When we do that, we'll end up with 2x squared minus 8x minus 24. So that's how we come up with the unfactored form, or the original form of the rational function. So this guy right here, that is my expanded form. Now from here, what we want to do is use Desmos to check to make sure we did this correctly. Because if we mess up in the original part, then we're going to go ahead and everything else we do is going to be wrong. So we want to make sure that that is correct. So we're going to take the expanded form and put that into Desmos, and then we're also going to take the factored form. So we're going to put both of those into Desmos. So I'm going to have you go ahead and hit pause, type those into Desmos, and I'll see you back here in a moment. Now, after you have those in Desmos, notice both lines match up on each other. So as I'm typing everything in, you'll see the two lines are kind of wonky a little bit on there. They're not quite lined up. They're not really adjusted. But then as we continue to type that in, we'll end up with two functions that one is just sitting right on top of another. So that's awesome. We've got that all set. Now, on to determining the equation for the slant asymptote. All right, now one of the things I want to talk about first when we set this up, I want to go back to some numbers here, like 2/8. Now we know as a fraction, that would reduce down to 1/4. So my question is, which way do we set this up? Do we go 2 going into 8 like that, or do we go 8 going into 2? One of those is correct and one of them is not correct. Now we know what I want you to pay attention to is this numerator right here. So the numerator is going to be this part that I want to focus on. So the numerator, if I go in choice A, 2 going into 8, ooh, I know that's 4. Well, if I compare this answer to 1/4, I know they're not the same thing. So that would not be the correct solution because 4 times 2 gives me 8, and that would just give me 0. However, if we took 8 going into 2, then that is 1/4, because 1/4 of 8, if I took 8 and made 4 groups out of it, 4 equal groups, each group would have 2. So 1/4 of 8 is 2, and so that is the version that we want. So we want the numerator to be on the inside underneath the division bar. So when we set this up, the numerator goes underneath, just like that. Now, before, there's going to be a little bit of a pattern here. And this pattern, I want you to pay attention to this 2 right here. And then we didn't have a coefficient in front, but that would be 1/2. All right? Or you could look down here in front of the x cubed, there'd be a leading coefficient of 1, and then the leading coefficient of the x squared would be 2. So that's going to play a part into our pattern here. Now, when I look at these two terms, in my brain, I'm kind of thinking to myself, x cubed, that's the same thing as 3x's. And then if I divide that by this term on the outside, just the 2x squared, that would be the same thing as 2 and then x and then x. Now I know these are going to cancel out, they're going to reduce to 1, so I'm just going to be left with x over 2. All right, so we're going to have that x over 2. So what I'm going to do is write that as 1/2 x, because that means the same thing. And I'm going to take 1/2 x and multiply it by each term around on the outside. So I'm going to have an x cubed when I multiply 1/2 x times 2x squared. 1/2 x times minus 8x gives me minus 4x. And 1/2 x times minus 24 gives me minus 12x. Now a little note right here about this part. Check this out. So there, again, here's another pattern that I want you to notice. This x cubed minus 4x minus 12. Where have we seen that before? If we look up here in the factored form, right after we distributed everything, look at what we got right there. X squared minus 4x minus 12. Samesies. Coincidence? I think not. All right, because that is what is true about all mathematics. It's all based on patterns, and so you want to see when you can recognize some of those patterns. Now, when we subtract these two terms, be real careful here, because don't forget to switch the signs. First term, that's going to cancel out. This minus 4x is going to change to plus 4x, and when I combine those two terms, I'm going to end up with, when I forgot the squared there, when I combine those, I'll get a 2x squared. And then lastly, when I combine the minus 21, and this is going to switch to plus 12x, that is going to give us minus 9x. And then don't forget, bring down the minus 18. Now, when we have this part, this one's kind of nice, because if I just take a look at 2x squared right here, going into this 2x squared right here, so those two terms, when I divide those, one into the other one, so that's 2x squared divided by itself, is just going to give me 1. Because you have 2x squared over 2x squared, that simplifies to 1. So that's real nice. 1 times that whole trinomial is just going to give me 2x squared minus 8x minus 24. So there we are with that. When we subtract that, we don't really care about the answer, but that answer would give us negative x and then plus 6. So now, this piece right here, that's my slant asymptote. So the equation of the slant asymptote, so we'd write that like this. We can just put SA for slant asymptote. Now make sure you put y equals, because it is the equation of a line. Y equals 1/2 x plus 1. Now if I put this in Desmos, so here's my slant asymptote equation right here. Now I'm going to go back to Desmos and put that equation in. And check out what happens here. Notice that the function is going to hug really, really close on different parts of that. So you want to notice that. And then don't forget, for asymptotes, you want to slide over, change the color to red, and then make it a dashed line also. All right, so that's going to be one of the pieces we're going to make sure that we do in our project. So all asymptotes are always going to be red and dashed. All right, so that's how you change those. So that's it for this video. Thank you guys for watching. I appreciate you. Hopefully by now you understand how to do that polynomial long division to figure out the equation of the slant asymptote, while also using Desmos to check yourself before you wreck yourself. All right, you guys make it a great day as always, and I'll catch you later. Peace out.